Adsorption. Introduction. Charcoal powder is used to remove brown color of raw sugar to make it white. It was also observed that metals like platinum, nickel, palladium have tendency to take up large quantities of hydrogen gas on their surfaces and act like a catalyst in hydrogenation of unsaturated organic compounds. All these phenomena can be explained on the basis of surface property of solids or liquids called adsorption. Concept of adsorption. The molecules on the surface of solids and liquids behave in a different way as compared to the molecules in the bulk. This is because the molecules inside the bulk of the solid or liquids are attracted equally from all the sides, as shown in the figure below. But the molecules on the surface of a solid or liquids are subjected to an unbalanced attraction from the solid or the liquid side. Due to this unbalanced attraction, molecules on the surface of solids or liquids tend to drag inside the bulk. As a result of these unbalanced forces, solids and liquid surface tend to satisfy their unbalanced forces known as residual forces by attracting and holding on their surface gases or dissolved substances with which they come in contact. As the molecules of these attracted species remain only at the surface and do not go deeper into the bulk, their concentration at the surface is more than in the bulk of the solid or the liquid. Thus, adsorption is the surface phenomenon in which the adsorbate accumulates on the surface of the adsorbent. Definition. The phenomenon of accumulation of one substance on the surface of some other substance is defined as adsorption. Types of adsorption. Gas, solid system. Example, adsorption of any gas on charcoal. Liquid solid system. Example, adsorption of acetic acid on charcoal. Gas liquid system. Adsorption of gas on mercury. Absorption. The phenomenon in which a substance penetrates through the surface and gets uniformly distributed throughout the body of the other substance is called absorption. Difference between adsorption and absorption. Adsorption is a surface phenomenon. Absorption is a bulk phenomenon. In adsorption, one substance accumulates on the surface of another, increasing the concentration on the surface. In absorption, one substance penetrates the body of another and gets distributed uniformly. Adsorption is accompanied by evolution of heat. Absorption is not accompanied by evolution or absorption of heat. Adsorption depends upon temperature and pressure. Absorption is independent of temperature and pressure. Adsorption is reversible. Absorption is irreversible. Adsorption takes place due to unbalanced residual forces. Absorption takes place due to porous nature of the substance. Adsorption is rapid in beginning and its rate slowly decreases. Absorption occurs with uniform rate. Example of adsorption is accumulation of hydrogen gas on charcoal. Example of absorption is blotting of ink by blotting paper. Adsorbate. The substance which itself gets adsorbed on the surface of another substance is called adsorbate. Adsorbent. The substance which adsorbs the other substance on its surface is called as adsorbent. For example, in the process of adsorption of acetic acid by charcoal powder, charcoal is the adsorbent and acetic acid is the adsorbate. Forces between adsorbate and adsorbent. The adsorption occurs because of attractive forces exerted by atoms or molecules present at the surface of the adsorbent. These forces are physical forces or van der Waals forces or cohesive forces. These are weak and non-specific in nature. Chemical forces. These are strong and specific in nature. Types of adsorption. Physical adsorption. Physisorption or van der Waals adsorption. When the molecules of adsorbate are held on the surface of adsorbent due to weak van der Waals forces, the adsorption is called physical adsorption or physisorption or van der Waals adsorption. For example, adsorption of hydrogen gas by charcoal. Chemical adsorption. When the molecules of an adsorbate are held on to the surface of adsorbent by formation of chemical bonds, the adsorption is termed as chemical adsorption or chemisorption. For example, adsorption of oxygen on tungsten to form tungsten oxide on the surface. Factors affecting adsorption. Nature of adsorbate. The gases get adsorbed more rapidly than liquids and solids. The easily liquefiable and highly water-soluble gases like ammonia, HCl, Cl2, SO2 get adsorbed more rapidly than other gases. Because these gases have greater van der Waals forces of attraction as compared to the other gases. Example, hydrogen, oxygen. The gases with high molecular weight also get adsorbed to a greater extent. Nature of adsorbent. Extent of adsorption depends upon surface area of adsorbent. Adsorption is more on rough surfaces, porous solids and finely divided adsorbent as they provide larger surface area. Example, finely divided charcoal, nickel, etc. Temperature. Adsorption is an exothermic process. According to Le Chatelier's principle, decrease in temperature favors adsorption. Thus, adsorption varies inversely with temperature. It is true for physical adsorption. In chemical adsorption, rate of adsorption increases and then decreases. Pressure. Pressure has natural tendency to keep the particles together. Hence, adsorption depends on pressure. At low pressure. Initially at low pressure, adsorption is directly proportional to pressure due to the availability of maximum surface area of the adsorbent. At moderate pressure, adsorption further increases with increase in pressure, but it is less rapid due to availability of less surface area of the adsorbent. At high pressure, after the point of saturation, adsorption remains constant even though pressure is further increased. This is because surface area gets completely covered with gas molecules. Concentration of adsorbate. The rate of adsorption increases with the increase in concentration of the solution of the adsorbate. The increase continues up to a certain limit till equilibrium is achieved. Surface area of adsorbent. The substances having porous nature, finely divided powders and rough surfaces provide larger surface area. Hence, they act as good adsorbents. Freundlich adsorption isotherm. The empirical equation showing the relationship between the amount of an adsorbate adsorbed by a unit mass of an adsorbent and the equilibrium pressure at a constant temperature over a limited range of pressure is called as Freundlich adsorption isotherm. The mathematical expression is x upon m is equal to k into p raised to 1 upon n for gas-solid system, or x upon m is equal to k into c raised to 1 upon n for liquid-solid, where x is equal to mass of adsorbate, m is equal to mass of adsorbent, p is equal to equilibrium pressure of gas, c is equal to equilibrium concentration of the solution. The value of 1 upon n is given by 1 is greater than 1 upon n is greater than 0. Applications of adsorption. In purification of water. Adsorption can be used in purification of water. Charcoal. When impure water is passed through charcoal, it adsorbs water-soluble impurities. Charcoal is porous in nature, hence it acts like a filter and separates the soluble impurities. Alum is a good coagulation agent. Therefore, it coagulates some impurities in colloidal form from water. Alum gives white gelatinous precipitate of AlOH thrice on hydrolysis. This AlOH thrice precipitate acts as a good adsorbent and adsorbs some impurities from water. Due to adsorption, particle size increases. They become heavy and they settle down at the bottom. Permutate. Na2P or Na2Al2Si2O8. Soluble impurities like Ca++, Mg++ are responsible for hard water. These cations can be removed using permutate. This permutate exchanges sodium with calcium and Mg++ from hard water and makes it soft. The reaction is Na2P plus Ca++ gives CaP plus 2Na+. Na2P plus Mg++ gives MgP plus 2Na+. Adsorption indicator. Dyes like fluorescein, eosine can be used as an indicator for the titration involving formation of precipitate. Example, eosine can be used as an indicator for the filtration between AgNO3 and KBr involving formation of yellowish-white precipitate of AgBr. When AgNO3 solution is added from the burette into the KBr solution containing few drops of eosine as an indicator, when yellowish-white precipitate of silver bromide, AgBr, is formed. AgNO3 plus KBr gives AgBr precipitate plus KNO3. Ag plus Br minus gives AgBr precipitate. This AgBr adsorbs Br from KBr solution and forms AgBr. This AgBr adsorbs Br minus from KBr solution and forms AgBr, Br minus. This anion has no reaction with eosine, which is used as an adsorption indicator. When more and more AgNO3 is added from the burette, more and more AgBr precipitate is formed, adsorbing more and more Br minus. A stage will come at which Br minus will not be available for the reaction with added Ag plus ions. At this stage, AgBr precipitate adsorbs unreacted Ag plus and forms AgBr, Ag plus. This cation reacts with negative part of eosine. Therefore, color of precipitate changes from yellowish white to pink. This is the end point of the titration. Catalysis. The process which increases the rate of a chemical reaction by adding a substance called catalyst is called catalysis. Many metals are used as catalysts like palladium, platinum, nickel, etc. These metals have tendency to adsorb the gases like H2, SO2, N2 and O2 on their surface. Hence, these metals are used as catalysts. Adsorption is an exothermic process. The heat of adsorption is used to activate the reacting molecules. Thus, process of adsorption also provides the energy of activation for reactants. Hence, the rate of the reaction increases. For example, nickel is used for hydrogenation of oils. Finely divided iron is used as a catalyst in the manufacture of ammonia from nitrogen and hydrogen in Haber's process.